chose to use a tracked mobility since the wildfire exists in challenging terrains with slopes. While it may look slow in these videos, I should state that I only...
Welcome back everyone. I'm super excited to wrap up this 2 months long project. I've been building a robot for Wildland Firefighting. Part 1 is me presenting the idea to the judges and to the public. And this is a multi-series that I'll be showing you how I built the robot and what kind of challenges that I have and what it can do in the future. So sit back, relax, and enjoy.
Good morning, judges, staffs, and general audiences. Just of last year, there were 60,000 wildfires reported. While experts from NASA analyzed that the frequency of wildfire occurrence has remained similar, the size of the burn area has increased annually. Thinking about the California fire recently, it was estimated that the area covered was 2,000% more than last year, a little bit of an outlier. On the other hand, the firefighting workforce has reported to onboard a little past the hiring goal. Despite this, we still face the lack of firefighting support with the growing size of fire each year. To give you a perspective on the scale of manpower, more than 7,500 firefighters were deployed during the California fire, and recently multiple agencies are actively combating Florida fire, even as we speak. My point is, firefighting really is labor intensive. Now, to understand the wildfire workforce a bit more, there are 3 categories for the hand crew. While we won't dive into each category, all of them are in charge of utilizing some sort of hand tools. These hand tools are used to construct fire lines. They could be chainsaws, axes, shovels, and more. These fire line constructs are extremely labor intensive, time consuming, and most certainly dangerous. In addition, the challenging terrain, lack of tool accessibility, and situational awareness are hindered during these wildfire fighting. Hi, my name is Nathan. I'm a robotics engineer. My background is in autonomous vehicles, medical simulations, and fire tech. My proposed solution is something that could autonomously construct fire line, amplify situational awareness, relaying real-time data, deploy rapidly, most importantly, reduce the risk of firefighters while constructing the fire line. And this is my prototype, the Guardian. For the Guardian to have self-driving capabilities, I installed various sensors. There is an onboard infrared camera, IR camera, which helps see through smoke, identify fire and objects, and helps navigation. It also equips with LiDAR that could help analyze and map the terrain, to aid in detection and navigation as well. Both of these sensors can well be operated at night to enhance visibility. We can locate the Guardian based on its GPS signal. Now, I wanted to clarify that even without the onboard GPS, the Guardian will be able to navigate in a GPS-denied area. As for the real-time datacom systems, I will be implementing IoT 5G, and future considerations for Starlink or LoRa mesh. 5Gs are widely available nowadays, with Starlink adds another safety net in case of network traffic. The LoRa mesh introduces long-range capability while creating internal network communication to other fleets or crews. And just to give a perspective, it is up to 3 to 10 miles with or without line of sight for LoRa. Here's a sneak peek of my prototype at a 1/5 scale, so it's relatively small for now. I chose to use a tracked mobility since the wildfire exists in challenging terrains with slopes. While it may look slow in these videos, I should state that I was only using 11 volts of power for this, which means the Guardian could run a lot faster. And here are my potential softwares. On the left side, it is utilizing LiDAR in a 2D platform to map the terrain. And this is just an early example of the prototype. So you can see it's kind of exploring and then map out its environment around. And here on the right side, I prototyped a way to drop a waypoint for the Guardian to navigate, avoid obstacles, and reaching to its determined mission point. I'll fast forward a little bit. You can see it estimates its pose positions all the way to the waypoint. And here's what a 3D mapping could look like. This is the concept called SLAM, simultaneous localization and mapping, a very common technique and standard used for autonomous vehicles. In short, the Guardian consistently estimates its own position while mapping newly explored environment into its memory. And here's just another example of the Guardian and what it could see. But also for the operators if they so choose using the remote control. So what's the use case? With the self-driving capability equipped, firefighters or incident commanders can command the Guardian to perform waypoint missions for scouting, fire line constructions, or even follow along with the crew. Just simply drop the waypoints or draw a line on the georeference, then the Guardian will execute its mission. The utilization of thermal imaging and other sensors could help collect and assess the temperature and wind dynamics, as well as humidity level. All of these informations gives better insight to the commander in making critical decisions. With the onboard LiDAR and camera, we can perform some really sophisticated object detection and terrain navigation. It also serves as a video stream to the incident commander to monitor the situation. The mentioned IoT 5G enhances crew communication and introduces capabilities for teleoperation for the Guardian. In other words, you can remote control. To address the data security, I will be migrating to TAC ecosystem as it has been widely adopted by the first responders and military personnel. The Guardian aims to be lightweight, well ruggedized, and thermal proof. With these considerations, I will be experimenting and have been experimenting with materials like PEEK and FRP, fiber reinforced plastic. With the weight reduced, the Guardian could potentially be deployed from air support and perhaps along with the smoke jumpers. With the network capabilities, multiple Guardians could form a fleet to achieve fire line constructions together. Now, the Guardian wouldn't be complete without a machining tool. I'm actively exploring a new design that couples existing technique from the tiller machines or trenching machines. With such, the Guardian should be compact enough to navigate challenging terrains while still packed with power to construct fire lines. And at the very least, this design could carry simple supplies like the fire shelter, the SCBAs, and while clearing its own way without the interference from a firefighter. And as a design consideration, I have to be honest that I kind of neglected the important fact of the floor-down soil type. Just of yesterday, Tom Coletti mentioned that their tracked equipment was kind of stuck in the terrain due to the soil type. They have dry vegetations above and have wet ground underneath. So this, I would have to address this immediately. I'm thinking of utilizing airless tire as it is widely used by the military and NASA rovers to address similar terrains. The tiller trench mechanic remains a little bit challenging for me, as I would have to consider the hard rocks underneath the soil, but from existing research, this seemed to be highly achievable. Now, let's address the immediate future for the Guardian. I'd like to emphasize that all of these designs and implementation have been proven to some degree. For example, folks from various universities have been doing off-road autonomous navigation. While I have not seen people tracking the really rough, rocky terrain portion, with recent advancement in AI and reinforcement learning, we start to see a glimpse of hope for navigating extreme terrains. And while some companies have similar ideas in building machines that could shove its way, they still weigh a ton and requires heavy supervisions and operation, which takes away the attention from the firefighter who are already focusing on wildfire. My ultimate goal is for the Guardian to form alliance to existing firefighting pipeline, and without any need to interfere or control. It should help bridge the gap of labor, reduce firefighting fatigue. In addition, there is a huge cost incentive, as the ground autonomous solution is significantly cost-effective than aerial suppression. To give a perspective, helicopters take water that could cost hundreds of dollars per hour, and the 747 super tanker could cost up to $60,000 per drop of fire retardant. On an off-season, the Guardian could perform site tasks like any other robots, performing delivery, assess environments for scientists, you name it. While this may sound too good to be true, the innate nature of the autonomous vehicle with onboard sensors can in fact achieve a wide range of missions. So beyond this, what are some further innovations? Well, as I sat down and reviewed my notes, I remember Kevin Hires made an emphasis of nighttime operation, boulders dropping, and tree striking on firefighters, to which I believe the Guardian could address these issues. With the onboard sensors originally designed for the Guardian, it comes natural to implement state-of-the-art hazard detections. The IR thermal camera would be able to gather and assess environments a lot better than our naked eyes. The terrain mapping could be assessed by experts in real time as we send data out. And in addition, while I believe many competitors here have astonishing capabilities and technologies to easily carry payloads of SCBAs and fire shelter, I would like to further address some potentials I see utilizing an autonomous vehicle as Guardian material. You see, the Guardian would already have to be thermal ruggedized, to which it could be utilized as a thermal shield, deploying several radiant barriers around a fire shelter. And God forbids, when a mayday is called, the Guardian would serve as a lifeline beacon, giving accurate GPS coordinates while delivering real-time environment data to the RIT team. This is why I decided to name it the Guardian. It can go before us, serving as the eyes. It can stay behind us, serving as the last defense. And here's just a quick overview of the design matrices, which is in the document details. Lastly, I want to use this public stage to thank all of the first responders, and to those who have helped me and worked with me. I wholeheartedly respect those men and women in the front line, and am grateful to be part of this innovative mission. If you'd like to collaborate with me, I'll leave my info in the chat below. And thank you.